We will also talk about the extensible and customizable capabilities of Copilot, mainly in plugins and skills. I will go straight into a demo on how we can use a custom plugin for SCOM in an incident investigation with Copilot for Security to help provide further value and enrichment to an incident investigation use case. Next, I will share a bit of my experience in the field on how our customers today are leveraging SCOM to monitor their hybrid cloud ecosystems, and that there is an opportunity to further extend Copilot for Security with SCOM as a source it can leverage to provide further value to its different use cases. And finally, I will go into detail on the approach that I have developed to create a custom Copilot for Security plugin for SCOM and the steps I took to build a proof of concept to showcase how to test and validate the plugin in an incident investigation session with Copilot. So the diagram on this slide shows the data flow of Copilot for Security. This diagram is referenced from the Microsoft Learn website. It shows that Copilot for Security's capabilities can be accessed through the standalone experience as well as the embedded experiences available in other Microsoft security products. The blue dash box shows all the components operating inside of the Microsoft Security Trust Boundary, and the numbers in the data flow diagram show the various pre-processing, processing, and post-processing steps to get the formatted response to the user. Our custom plugin for SCOM will largely follow this flow through the standalone experience. So once the prompt or input from the user is sent to Copilot, it determines which plugins to leverage during pre-processing. Then it sends the modified prompts to the large language model and receive a response on the plan to fulfill the user's request. Copilot for Security then accesses the plugins to gather information and to take action to post-processing. Then it performs responsible AI checks on the response, where it checks that the response is appropriate or not malicious. And after a final validation with the plugins, the prompt response is given back to the user prompt in the standalone experience or within the embedded experience of these Microsoft security products. So Copilot for Security is intuitive, customizable, and extensible while supporting responsible use of generative AI. It meets users where their daily workflows exist and natively integrates with existing tools through the standalone and embedded experiences in other Microsoft security products. Double-clicking into the customizable and extensible side of Copilot for Security, today, capabilities like custom plugins, custom prompt books, logic app connectors, and knowledge-based integration empower users and the teams they collaborate with to use Copilot together with their organization's existing processes, tools, templates, and workflows to accomplish their daily task. For this session, we will be focusing specifically on custom plugins and how to utilize it to bring in internal knowledge from your own security ecosystem to further extend the functionality and enrich the prompt experience in Copilot for Security. So first, what are plugins? Plugins are additions to large language models to enable advanced and custom functionality. It allows you to extend Copilot for Security into your workflows and experiences. You can connect your business data sources, internal knowledge, keep data and applications where they are, and build your knowledge into the system with enriched information that is grounded within the context of your organization. So how can someone in Copilot for Security leverage plugins? Copilot for Security comes with many pre-installed plugins from first and third-party applications and services. Pre-installed plugins are available out of the box and allow Copilot to source information when responding to your prompts. Custom plugins, which is what we will be focusing on this session, extends Copilot's capabilities by integrating with third-party solutions or adding custom functionalities. Copilot for Security respects existing user permissions by using on behalf of authentication flow to provide access to other Microsoft services that your organization already has access to. The product has the same permissions of the user using it, so there's no situation where the product has a broader set of permissions than the user interacting with it. And you can build your own custom plugins, API, GPT, or KQL to perform specialized tasks or enrich your investigations. And the type of custom plugin that we will be exploring in our demo later to bring in environment-specific monitoring data from SCOM into Copilot will be a KQL plugin. And finally, plugins enable dynamic product experience for each user. Copilot users can switch on and off specific plugins that they want to be considered for the sessions they are creating to enrich their prompt experience. Therefore, everyone's Copilot experience could possibly be different in different environments. So let's circle back to the main objective of this session today. That is on the advantages and how we can further extend Copilot for security with more enriched information by building on the internal knowledge, experience, and workflows for monitoring, management, security detections that you have operationalized in your SCOM environment to get the maximum value from your Copilot for security deployment. And how are we going to achieve that? Yes, by utilizing custom plugins in Copilot for security like we just touched on in the previous slides. So without further delay, let us first walk through an incident investigation with Copilot for security and demonstrate how we can leverage a custom plugin for SCOM to help provide further value and enrichment to the incident investigation session. So important note is that in order for me to accelerate through the demo without the wait time required when prompting a large language model, I'm using screenshots instead. These screenshots I took from the first time I tested this custom plugin in a Copilot for security workspace that is unfortunately not publicly accessible. So in this example, we will start the investigation in Microsoft Defender XDR. I will be using Copilot for security to perform a comprehensive incident investigation on a suspected brute force attack involving 2 devices in a role as a security analyst. We know that analyzing and understanding the events and information of Microsoft Defender incidents involves a lot of work and is a time-consuming task for security analysts. A lot of these security detections from Defender rely heavily on monitoring and observability of systems under management for security information collection. Aside from that, at the same time, there's also a wide set of customers using SCOM and Microsoft Defender in tandem. So let's see in this scenario how we can extend Copilot for security with the richness of information and experience in SCOM to further improve and enhance the incident investigation experience. So as an analyst, I start my day inside of my company's endpoint solution, which is Microsoft Defender XDR. Copilot for security is integrated in Microsoft Defender XDR. From the incident page of the suspected brute force attack incident, we can select the Copilot for security button to get a summary of the incident and get details such as the time and date of when the suspected attack started, the entity or asset that started the attack, the protocol used and assets involved in the attack. Then, by selecting the Open in Copilot for Security button, I can extend the investigation using natural language prompts and more plugins by continuing the investigation in the standalone experience of Copilot for Security. I can now continue my prompting session in the standalone experience with a natural language query. List the device involved in incident 2411 from Defender. The response lists the DNS name of the device involved with some additional properties. Copilot for Security offers a level of transparency with its process log by showing the user the plugin chosen as the response is being formed and how long it took. This helps build trust in Copilot for Security and allows users to verify if it is delivering accurate and appropriate responses and empower the user to detect fabrications. In the process log shown on this slide, the incident analysis skill of the Microsoft Defender XDR plugin was chosen as requested from the initial query prompt. We also see in the process log that the response has first been reviewed by Microsoft responsible AI models for anything malicious or inappropriate. before the response is presented to the user. Now, it's time to query another source to see if there are additional information about the two devices involved in the incident I am investigating. To query my custom Copilot plugin for SCOM for insights, I submitted a prompt in natural language, and the Copilot orchestrator is able to choose the right custom plugin skill. Here, Copilot was able to recognize what these devices are, right? Based on the previous prompt response context in the same session, and returns the latest security detection alerts triggered by SCOM. For both the devices in context, ZJump and ZDC. The response from Copilot also include additional properties for each alert like status, server role, and when the alerts were created and updated. We see here that there are two alerts found for ZJump, one still open and one already closed. From the same response, we also see that there are 6 alerts for ZDC and are still open alerts. Notice the set of information provided in the server role property included in each of the alerts found for ZDC and ZJump. This information will be stored in the session context and can be referenced in subsequent prompts. We will come back to that later. Now, I'm interested to find out more about the 6th alert. On multiple attempts were made to stop the connected machine agent. Let's take a closer look. So now I added an additional query. What are the risks if multiple attempts were made to stop the connected machine agent on ZDC? As shown in this slide, note that the connected machine agent is the Azure Arc agent. Here, we see in the process log that the generic capability is chosen. Therefore, the response to this prompt is generated based on OpenAI GPT-4 large language model, which is good at general knowledge and problem solving, as seen here from the response provided. The highlighted sentences were additional information that includes detailed explanation and recommendations provided by the large language model based on its general knowledge on the Azure Arc agent. This capability is incredibly helpful to a security analyst during an incident investigation to gain a better understanding of the risk implications of these security alerts while maintaining focus in the standalone experience and building context, and not having to pivot away to other search engines for further research and then reconsolidate with the main session context. Now, I queried the custom plugin for SCOM to return the threat scores. I used the prompt, get the most recent threat score for these two servers from SCOM. Again, Copilot was able to recognize what these two servers are based on the investigation context in the same session. And it returns the latest and highest threat scores for both of the devices in context, ZJump and ZDC. Here, I continue the investigation by asking which critical applications do these two servers belong to. Tell me their roles in that application and in the prompt. Remember before I highlighted that the information of the server role for each server is stored in the session context. So now we can use this information to enrich the response here. The highlighted sentences in this prompt response on this slide contains additional information from the session context and also the responsibilities of different server roles. And finally, to wrap up the incident investigation, I asked Copilot to write a report containing all the information in context, summarize the findings from the investigation, and conclude with a set of recommendations as shown in this example. This capability helps save time for me as a security analyst so that I can focus on more high-value tasks, actually pertinent for securing the organization while keeping my other stakeholders in the loop. Instead of having to manually write out summary incident reports. Here, we see that this incident report provided by Copilot summarizes the entire session context of the incident investigation enriched with valuable content from the custom plugin for SCOM and categorized into 4 sections: incident details, investigation findings, server roles with the name of the critical application involved, and provided a set of recommendations to improve the security posture of the affected devices, which can also be used to up-level skills for security analysts. The incident report can be further summarized to provide a non-technical executive level summary that can be shared with a company's leadership team. As highlighted on the slide, although the report generated is more simplified than the full report and easier to understand, it still maintains the important points and findings enriched by the custom plugin for SCOM from the session context. This concludes the end-to-end demo on how we can leverage a custom plugin for an external solution like SCOM to help provide further value in an incident investigation with Copilot for Security. Now, let's take a look under the hood on how this solution is built. Before delving deeper, here is an overview of this solution. The heart of this solution is a SCOM and an Azure Log Analytics integration, through which security and monitoring data generated from SCOM is made available to Copilot for Security via plugin. First, the solution uploads security-relevant SCOM data and context to a workspace using a PowerShell script. Then, using KQL queries, we are able to build Copilot skills to gather information from a log analytics workspace. When these skills are added into Copilot as a plugin, the magic of the large language model makes contextual analysis possible without needing the user to have skills with the source system. And as seen from the demo, Copilot for Security is able to retain context, merge information from different sources, and present an end-to-end story effectively. So let's take a pause here for questions. And also with another poll question as well, or survey question. Do we have any questions?
No questions.
If you, I will continue. But if you have any questions, please raise your hand, and I'm more than happy to respond. Yes, do you have so good results. Awesome. Okay, I will continue. Let me know if any questions. Shashank is in the call as well. Hello, Shashank.
Hi, Wei. Hello, everyone. If there's no question, maybe I can plant a question for the room.
Okay.
I saw that a lot of you use Azure Monitor and Log Analytics as a monitoring system in your environments. What do you think? Could you take benefit of what Wei has built, extend it, and leverage it for your environments, even though there's no SCOM? And you can use the chat to give me a response, or just talk aloud. I'm good.
Yeah. Yes, but interesting poll results as well. So do you use monitoring or observability events, performance or alerts as part of determining the security incidents? A lot of you say yes. Yeah.
Yeah. Does anyone want to share an experience? How do you use them? How has been your experience with it?
But we will pause later again for further questions. But as we go through, I'll pause as well. If any questions, you can also send your questions through the chat.
Yeah. Thank
or
you.
send your answers through the chat as well.
We have the quiet group today. Generally, our customer calls are pretty interactive. But May, over to you. Back to you.
Okay, I'll continue. Okay, so an advantage of connecting Copilot for Security to a product like SCOM is that it can potentially help increase productivity, thanks to Copilot's ability to simplify the complex. Yeah, we all know that SCOM typically has a rather steep learning curve and requires a lot of hands-on, like long hours of understanding the different critical components and capabilities, from administration to data types to infrastructure to authoring to operations and troubleshooting, right? This can be very challenging for junior or newly recruited analysts to learn how to operate or query SCOM for valuable information during an incident investigation or issue analysis in a short period of time, right? There's also limited bandwidth for the subject matter experts in the team to provide immediate response. Sorry. Or train new team members, as they could be busy or there could be a shortage of resources. These challenges cause delays in the incident getting resolved, staff fatigue, and increase the chances of error. With Copilot for Security connecting to a monitoring tool like SCOM as its source using a custom plugin, analysts don't have to connect and search through its operations console, run SQL queries or PowerShell scripts to query for the required information. They can just ask questions in English or natural language, and Copilot would understand the context based on the description defined in the custom plugin, sets the plan in motion, and invokes the skill to retrieve the required information into the prompt experience of the Copilot portal. This helps save the analyst so much time without having to search through the documents and source systems, which in this case is SCOM, or wait for a response from a subject matter expert, but instead getting timely, concise, and as needed information from the prompt response in Copilot. And furthermore, being able to summarize and generate reports with information in context to their customers. This would help the security or support team improve their efficiency and enhance their impact in contributing to the team and customer experience, and more effectively contributing to the success of their other team members. Finally, being able to simplify the complex helps bridge the gap between an on-premise systems like SCOM and newer capabilities in the cloud and in AI. This would also help place the subject matter experts in a better position in engaging their managers and leadership teams and communicate on their work coverage and expertise in a more accessible and effective way. And junior team members can perform more advanced tasks using their limited experience. And as the plugin is smart, so you don't have to be, right? And the senior ones focus on the hardest and more strategic problems. So before we go into detail on the approach to create a custom Copilot for Security plugin for SCOM, I would like to share a bit of my experience in the field on how our customers today are leveraging SCOM to monitor their hybrid cloud ecosystems. Over the years, as subject matter experts in the monitoring space, we have worked closely with large enterprise, small and medium-sized customers to help onboard and accelerate our multi-cloud monitoring solutions with SCOM and Azure Monitor to provide monitoring coverage for their hybrid cloud ecosystems. Many of our customers have large hybrid clouds consisting of an on-premise, Azure, and other cloud services setup, where SCOM is still deeply ingrained and heavily utilized in these environments, and monitoring the availability, health, performance, and connectivity and security state of thousands of virtual machines, network devices, hardware devices, remote hosts, and critical distributed applications with integration with third-party ticketing systems for alerting and dashboarding solutions. Many of these large SCOM management groups run thousands of detections and data collections workflows across their agent-managed servers or endpoints. These monitoring workflows are either defined in standard Microsoft management packs like Windows Operating System Management Pack, the SQL Management Pack, or Active Directory Management Packs, or defined in customized and proprietary management packs written internally or provided by third-party service providers. Many customers have mature lifecycle internally, developing in-house custom management packs that automatically discovers and monitors critical components of their imported applications. On the topic of security monitoring, I've seen quite a few SCOM environments with some form of customized security detections and assessment configured at a distributed application level or monitored server level. An example would be a use case where the health, availability, and performance of the Azure Arc antivirus Azure Monitor agents are being monitored by SCOM to ensure continuous security coverage, and also the flow and collection of security data is stable and consistent into their cloud monitoring and security services. As you may recall in my demo, I used an example where an alert was generated due to multiple attempts were made to stop the ARC agents on a server. So as you can see here, a mature, well-maintained and optimized SCOM environment will have tons of valuable monitoring information, detections, and insights that can be leveraged to help improve the overall health state and security posture of a hybrid environment and help drive capacity planning, rapid detection of issues, and incident investigation. And for environments with proprietary third-party or internally developed applications or workloads that could mostly be hosted or running on-premise, over the years, we have seen many organizations utilize SCOM to provide monitoring coverage to critical components of these applications, processes, or workflows through implementing ISV-developed management packs or through internally developed custom management packs. Developing these custom management packs would require internal knowledge, authoring skills, experience, and collaboration with developers and support teams in order to accurately identify these critical components to monitor and metrics to collect effectively. There are good examples of these types of many well-written management packs and monitoring solutions that have stood the test of time and still relevant to this day, running in SCOM management groups and of many organizations of every size in many industries and many parts of the world. And this is why we can leverage knowledge from management packs to extend Copilot with internal knowledge, insights, and workflows from mature SCOM environments to provide further value to security incident investigation, prompt enrichment, impact analysis, and security reporting. So before I move to the next section where I'll be demonstrating an approach that I use to create a custom Copilot for security plugin, let's pause again for further questions. Any questions from the audience? If not, I will continue. Awesome. So this plugin queries and retrieves environment-specific monitoring data generated from a SCOM environment to enrich the prompt experience in a prompting session within the Copilot portal. This integration approach is an extension from my previous work and research. It is a repeatable approach that I have developed to extract important, relevant, and aggregated monitoring data from well-tested management packs like the AD and the SQL management packs, or custom management packs like the ones written to monitor applications or critical processes using an external integration way on the management server side for the for Azure Monitor Logs consumption. So this approach starts by retrieving all the classes defined in a management pack or a group of related management packs of a specific monitored application, solution, or service using the get SCOM class PowerShell command. Then for each class, we can use get SCOM class instance, right, to retrieve information regarding each of its discovered instance or objects and information like object name, path, current health state, alerts generated provide a high-level view of the discovered and monitored state of a specific application or service monitored by a SCOM environment. With each of these monitor instances, we can drill in deeper to find relevant performance counter collected for them and their values, if any, over the last few hours and calculate the hourly mean, max, average as shown in this hierarchical view. Of course, alerts per monitored objects can also be extracted with this approach. Once the aggregated data mentioned in the previous slide is extracted using a PowerShell script running on a regular interval, it can then be converted into JSON and injected into an Azure Log Analytics workspace with the new Log Ingestion API or the Collector API that still works for now. The JSON payload can be sent from any systems or tasked via HTTP. So here's an example of how the SCOM records would look like in a custom table and searchable with KQL in Azure Log Analytics. With this approach, environment-specific and critical monitoring data collected from different applications by SCOM agents distributed across the management group can be retrieved, aggregated, and injected into an Azure Log Analytics workspace to be searched and analyzed. So for the demo, I wrote a custom SCOM management pack in my test environment to simulate a SCOM monitoring and security detection solution for a critical application in my demo tenant called Contoso. The distributed application is hosted across 6 servers of different roles as seen in the state view. The management pack of this monitoring solution includes class definitions of the different roles in the application. It also contains auto-discoveries for these server roles and targeted security detection rules and monitors for the specific class of servers hosting the Contoso critical application as shown in this diagram view. This management pack allows simulation of security detections in the form of SCOM alerts generated by rules and monitors, and these alerts can be triggered on demand for testing purposes. Here is the list of the security detection rules added into this management pack. Example, multiple attempts were made to stop the connected machine agents, security event logs was cleared, right? Local administrators group was modified, and so on, which is up to the MP author to add. So this means that I can control which security detections are triggered on which monitor servers that are discovered as a server role for the Contoso critical application. And I added another feature in the management pack to calculate the threat score for each server based on the number of distinct detections by these rules and monitors found on each monitor server across the security, performance, availability, and configuration categories. So I then proceed to use the repeatable approach that I mentioned in the previous section to extract important, up-to-date, and aggregated monitoring data from all components of the Contoso critical application monitored by the management pack and send it to Microsoft Sentinel for consumption every 30 minutes. 2 queries are used to produce output for Copilot. Here is what the data looks like in Sentinel when the KQL query is used to get the most recent SCOM security-related detections for all hosts or servers. And when the KQL query is used to get the highest and most recent threat scores from SCOM for all hosts or servers. With these KQL queries, I can start to build my custom multi-skilled Copilot plugin for SCOM, which is a KQL plugin. I will quickly go through the steps on how I built this custom plugin in the next few slides. So I start with the name of the plugin, then the display name, and the description. I then move to the skill group section. First and foremost, I specify the format or type that I'm using for this plugin, which is format equals KQL. Next, I define the skills that I want to invoke from my plugin. As with the two queries that I mentioned in the previous slide, each query will be added into their own skill definition section in the plugin file. Here is what the skill definition structure looks like. Starting with the first query, which can be used to get the most recent security-related detections from SCOM, we can add the KQL query under the template property of the first skill definition section template. Then give the skill a name, a description, and a meaningful name for the display name. And you can reference the plugin when you submit a prompt using natural language in Copilot, in the Copilot standalone experience, where it will go through the skill selection by the Copilot orchestrator. You can also allow the skill to accept inputs to be passed into as a parameter within its embedded KQL query. But in this instance, inputs are not required. The settings section for this skill is where you tell Copilot where to access the workspace to run the KQL query to gather the required information to take action. Therefore, you not only have to specify the tenant ID, subscription ID, resource group, workspace name in the settings section for Copilot to find the Sentinel workspace, but you also need to have permissions to access the workspace via the plugin from the Copilot portal, as mentioned earlier. And for the second query, which can be used to get the highest and most recent threat scores from SCOM, similar to the first query, we can add the KQL query under the template property of the second skill definition section. Then give the skill a name of the second skill definition, and give it a description and a meaningful name. Inputs are not required for this instance as well. Again, specify the tenant ID, subscription ID, resource group, and workspace name in the settings section for Copilot to find the Sentinel workspace to run the query for the second skill. And finally, we can save the file with the plugin information and the skill definition as a YAML or YAML file, which is a plugin manifest file. A plugin manifest describes metadata about the plugin and how Copilot can invoke it. With the YAML file saved, we can upload and publish the plugin manifest to Copilot for Security in the standalone portal. So admins can manage plugin permissions from the menu on the top left of the standalone portal, right? The first setting is who can add and manage their own custom plugins. This setting allows owners to determine whether contributors can upload custom plugins. The second setting is who can add and manage custom plugins for everyone in the organization. The default for this setting will allow only owners to be able to add and manage custom plugins that are available to all Copilots for Security users in the tenant or workspace. Okay, to validate whether the custom plugin for SCOM has been successfully uploaded and published, check whether the plugin has been listed under the custom section and whether it is enabled. Once the plugin is listed in the custom section, the display name and the description should match the display name and the description specified in the YAML plugin manifest file. You can also locate the two skills of this custom plugin by clicking on the prompt button on the right of the prompt bar in the standalone portal. The two skills should show up in the system capabilities section if you search for the keyword. In this case, the keyword is SCOM, as the word is part of the name and description of both of these skills. And they should match the display name and description specified in the YAML plugin manifest as well. And with that, I have demonstrated how we can build a solution that consists of a custom Copilot plugin for a solution like SCOM that is ready for a proof of concept to show how the plugin can be utilized and add value to an incident investigation scenario with Copilot for Security. So here are the key takeaways for this session. Building a custom plugin, a custom KQL plugin rather, for Copilot for Security is very straightforward. Right? Communicate with your security team on how SCOM is monitoring your hybrid environment and what internal insights it could provide about critical applications, services, and servers to add value to your security incident response processes. For more information and examples on how to create powerful plugins using KQL to explore your data and discover patterns, you can visit this Microsoft Learning page. And so in this session, we saw how custom plugins in Copilot for Security can bridge the gap between on-premises or legacy systems and newer capabilities in generative AI. Custom plugins allow you to build institutional knowledge into the system and extend Copilot into your workflows by connecting to your business sources. You can build your own custom plugins for SCOM to perform specialized tasks or enrich your investigation. The internal knowledge and insights from a healthy SCOM environment can be a valuable source of intel for Copilot in use cases like security incident investigation, impact analysis, and security reporting. And finally, Copilot's ability to simplify the complex helps flatten the learning curve for SCOM, resulting in time save, increased productivity, and can unlock new skills for more junior analysts and senior practitioners. So let's go to Q&A again. Any questions so far?
No questions.
Yeah, can you post the last survey question or poll question? Okay, just yeah, submit your response as well. Yeah. Yeah. Any questions? And yeah. Okay. And then number 5, can you post number 5 as well? Last question that I have for you. Is SCOM still running and playing a critical role in monitoring or observability in your environments? 50-50 for now. Okay, 50-50. Yeah. So SCOM has a lot of valuable data in it. Is it possible for Copilot to make automatic remediation in the next step? Automatic remediation. There's writable plugins, right? So that would be in future sessions. From Coder Aldo, can you can you clarify? Can you elaborate on your question, please? Or can you come off mute? Like to make prompts for skills issues here. Can you come off mute to elaborate more on questions? Clodo Aldo? Prompt for vulnerability issues and their analysis. Is that related to SCOM from connecting detected from the SCOM environment? Or is it just for in general through using the other first 1P plugins? In general, okay. Yeah, that will be, we have guides in the learn page as well on how to use the 1P skills and the prompts to do that. No problem. Anyone else in regards to, using Azure Monitor, using SCOM, or, integrating and collecting what it's already doing, and then summarizing, aggregating it, send it to the workspace, and after that, leveraging it in your prompt enrichment. Oh, okay. Yeah. Aiden, your question is regarding complex prompt. I think there will be a session in the future on that, right? Josin? Is it possible to use logic trees in prompts? For example, for each link in this phishing email, analyze the link using these prompts. Yeah, this is under the complex prompt category. So in future, the product group will be able to provide more information or in subsequent sessions.
Where should I go to find out what session that is or find out more information about it?
Josin, can you?
Aiden, are you part of the customer connection program, the Security Copilot CCP? All our previous prompting sessions are there, and you can access the recordings. Let me know if you are not part of that community. I will drop the link here.
Yes, I'm part of the community. Would you say the correct recording was called again?
Well, we've had a few prompting engineering sessions. I think we've had about 5, and they were interactive, so a lot of demos. So I'm going to maybe just drop the direct links here. I'll pick them up from the team site, and then you can just access them. Important thing is you are already part of that community. Otherwise, you won't be able to open the links.
Right. Thank you.
Okay. Okay,
So
let's go. Keep going. How I think we can move forward.
I finished my content, so I'm just waiting for,
I see. Okay,
presenting.
so if we're done then, and if there are no other questions, I will drop the links to the prompting skills sessions that we've had in the past. And again, this is a the recording of this will be available in the Copilot for Security CCP team site in about 24 hours. So thank you so much, Wei. Thank you, Shashank, and for everyone for your attendance today. I guess I am giving time back. We finished early. If I could ask you to fill out the survey, the call survey, that would really help us understand what else you'd like, what other topics you'd like to hear in the future. I hope to see all of you again next week. We have our usual Thursday skilling session where we'll be covering another topic. Thank you so much. Bye, everyone.
Thank you, everyone.
Thanks. Bye.